press the bell icon on the YouTube app and never miss another update.
Yeah, hello dear students. So let me continue some more questions from work energy power. So in the last class I covered few problems from your assignment sheet. I hope that you covered most of the questions from your assignment sheet, because almost each and every concept is covered in work energy power. So recall all the concepts and try to solve the problem from your assignment sheet. And in this session, let me cover few more questions, okay, and remaining problems you have to solve in your own way, okay. So let me continue next question, and that question also covered, but let me continue again. So see the next one. A small block slides with a velocity v0 is equals to 0.5 root gr on the horizontal frictionless surface as shown. The block leaves the surface at point C. The angle theta in the figure is. See, they given a horizontal surface, on that a block is moving on a horizontal surface. If it moves with certain speed at a point C, the block is going to leave the surface. You know that when a block leaves the surface, normal reaction becomes 0, because when it leaves the surface, normal reaction becomes 0. See the given diagram. See, R is the radius of the circular path in this one. This is R, and theta. Block moves with a speed v, that is given 0.5 root gr, this v0, and they given this is b, given b, and here the block is leaves the contact, okay, and we know weight of this block acts vertically downwards. Weight of the block is acts vertically downwards, and if this is theta, this is also theta, and this mg resolved into two components. One component is mg cos theta, and here you know this is nothing but what? Normal reaction force, and one more force is acting. If v is the velocity, centrifugal force is acting away, mv square by r, okay, mv square by r. But as the block leaves the contact, normal reaction is 0. As the block leaves the contact, normal reaction becomes 0. From this diagram, n plus mv square by r is equal to mg cos theta, but n is 0, so we can write mv square by r, which is equivalent to mg cos theta. So again, see, we are getting v square is equals to gr cos theta. Okay, keep this equation as it is. So I got v square is equal to gr cos theta. And see, block starts with v0, and here when it leaves the surface, speed is v. So this is final speed, this is initial speed, and see what height it is going to travel. If see, this one is r, if this is r, this is also r, and see, this is the distance covered by the body, h. So what is this h? H is equals to, see, this is r, and this is r cos theta, r cos theta. So h is nothing but r minus r cos theta. So what is h from the given diagram? H is equals to r minus r cos theta, nothing but r1 minus cos theta. So that is h. So use v square minus u square is equal to 2a as formula. You will get the answer. Otherwise, you apply the energy at this position and energy at this position, position A and position C. So here v square minus v0 square, 2a nothing but g, s nothing but h. So v square minus, so what is v? V is gr cos theta, okay, gr cos theta. Take this v0 square right side, v0 square plus 2g, h is nothing but r1 minus cos theta, r1 minus cos theta, okay. So gr cos theta V naught square is given 0.5 root gr. 0.5 nothing but 1 by 2 square means 1 by 4 gr plus 2 gr minus 2 gr cos theta. So gr everywhere cancelled out. Take cos theta left, it becomes 3 cos theta, 3 cos theta, and 1 by 4 plus 2, 9 by 4. So 3 is a cos theta is 3 by 4, theta is equals to cos inverse of 3 by 4. See, we got cos inverse of 3 by 4. Or if you remember the one shortcut formula, then you will get this answer in a matter of one step. I hope you remember the formula that is covered in our conceptual class. So that formula is cos theta, which is equivalent to V naught square by 3gr plus 2 by 3. So if you use V naught square as 0.5 root gr, then you will get the same 3 by 4 answer. Already concept is covered in previous video classes. Okay, so take this. Yeah, same answer. Okay, so second option is the correct option. Oh, yeah. See the next question. So next one, easy question. See, a tennis ball dropped from a height of 2 meter rebounds only 1.5 meter after hitting the ground. What fraction of energy is lost in the impact? Okay, so tennis ball falls from a height of 2 meter, rebounds to a height of 1.5 meter after hitting the ground. So let us suppose ball falls from a height of h1, rebounds to a height of h2. We know the fraction of loss of energy. Formula h2 minus h1 by h1 into 100. So just take the magnitude, the fraction of loss. Fraction of loss is h1 minus h2 by h1 into 100%. If options are in percentages, so you can use 100%. Otherwise, what is h1? 2. 1.5 by 2. 2 minus 1.5, 0.5 by 2. So answer is only 1 by 4. Okay, so 1 by 4 is loss of energy. Okay, see the next question. So next one also direct question and easy question. Power applied to a particle varies with time. The given 3t square minus 2t plus 1 watt. The change in kinetic energy between 2 seconds to 4 seconds. See the given the power is 3t square minus 2t plus 1. Asking to find change in kinetic energy. We know work done is equals to change in kinetic energy, and we know power is equals to work by time. That work nothing but change in kinetic energy from work energy theorem. So we can write power is work by time. Okay, we can write dw by dt. So dw is equals to p dt. So apply the integration with limits they mentioned from 2 to 4 seconds. So this is w, this w nothing but from work energy theorem, it is equivalent to change in kinetic energy. So power is 3t square minus 2t plus 1 0 to 2 to 4 dt. This w, okay, let me write at the end, and 3t square nothing but 3t cube by 3 minus 2 t square by 2 plus t 2 to 4, 3 3 2 2 gets cancelled, and this is nothing but kf minus ki t cube. Substitute this value, 4 4 za 16, 4 za 64 minus 4 square 16 plus 4 minus, substitute the lower limit, 8 minus 4 plus 2. So verify the answer, you will get 46 joule. So verify the answer, you will get 46 joule. So it is a simple integration question. Okay. So see the next one. Yeah. See the next. So this is also a good question. A 1 kg mass is projected down a rough circular track whose radius is given 2 meter, placed in a vertical plane as shown. The speed of the mass at the point A is 3 meter per second, at point B is 6 meter per second. How much work is done on the mass between A and B by the force of friction? See, the body is moving. Here in this question, body moving in a circular track with some different speeds. Initial speed is given, final speed is given. Okay, but here some work is said to be done by the friction also. Okay, they are not given coefficient of friction, but we can find work done by the friction. Anyhow, the body moving from A to B, what height it is moving now? 2 meter height. Means some work is done by what? Gravitational potential energy. Another work is done by friction. And of course, no doubt that work done by the gravitational force and work done by the friction, which is equal to change in kinetic energy. So let us use again a direct formula. Work done by the gravity, work done by the friction, which is equivalent to Kf minus Ki. Then it's completed now. Kf minus Ki. Target is to find out work done by the friction. By the gravity, very clear, mgh. Friction is our target. Kf half m v square half m u square. So work done by the friction is equal to half. Mass is mentioned 1 kg. Final speed is given 6, nothing but 36. Half m 1 kg. Initial speed is given 3, nothing but 9. Minus, take this mgh right side. M g, let us suppose 9.8 or 10. Okay, so 10. Height, how much the height? 2. So 2, this is 18. Okay, 2, 18, and this is 4.5 and 20. So 18 minus 4.5, 22.5 minus 20 approximately, otherwise 19.6. So you will get 2.5 joules. Okay, so check the calculations. You will get 2.5 joules. Show the remaining options. How much it is now? 2. So 2.5 option itself is not there. Show me the first option, 7.5. Okay, no problem. Verify the calculations. Yeah, you can go for the next question. Yeah, verify this one. See, previous one is okay. Half mv square 36 9. Yeah, method is correct. Maybe the value, just you verify the calculations. See the next one. Two putty balls of equal mass moving with equal velocity in mutually perpendicular directions stick together after collision. If the balls were initially moving with velocity 45√2 meter per second each, the velocity of their combined mass after the collision. Anyhow, they given two putty balls which are moving perpendicular to each other, asking to find velocity of the combination. Okay, the two balls, how they are moving? So this is also a direct question. See, this is moving with 45√2 meter per second, and one more is moving perpendicular to each other. with what speed? 45 root 2 meter per second, and they are combined here. Okay, they are combined indirectly, so the two are coming like this. They are combined. After the combination, that mass will have some speed. Let us see what is the speed. So you can use the momentum concept to solve this. What is the resultant momentum? P is equal to root of P1 square plus P2 square, because they are moving perpendicular to each other, and this is m something v dash. What is m? 2m combined, and this is root of m square v1 square m square v2 square. So no need of these many steps also. 2m v dash, 2m v dash. Here m square you can write outside. v1 square, what is v1 square? 45 root 2 whole square. So 45 root 2 whole square, 45 root 2 whole square. M gets cancelled. 2 v dash, 45 root 2 square, 45 root 2 square means you will get 45 into 2. 2 gets cancelled. V dash is equals to 45 meter per second. V dash is equals to 45 meter per second. So the second option is correct one. See, check the calculations in the previous problem. Previous problem is work done by the gravity plus work done by the friction, which is equivalent to change in kinetic energy, and I got work done by the friction, which is equivalent to Kf minus Ki minus mgh. Take G as a 9.8, you will get the correct number. I took G as a 10, you take the G as a 9.8, you will get correct number. Okay. Then see the next question. Yeah, this is also good question. See, a mass m moves with a velocity v and collides inelastically with another identical mass. After the collision, first mass moves with a velocity v by root 3 in a direction perpendicular to the initial direction of motion. Find the speed of the second mass after the collision. See, the first mass moves with a speed v and it is going to strike the body which is at rest. After the collision, the first mass moves perpendicular to the direction of the original component. See, let me draw the given diagram first. The given, this is moves, equal masses only, moves with a speed v. It is going to collide another mass which is at rest, they mentioned already. After the collision, first one, after the collision, see, one moves with a given v by root 3 in a direction perpendicular to the initial direction. So this, let us suppose first one moves with a v by root 3 and we don't know the second one. Let us suppose this is m1, this is m2 and this is m1, both are identical. Okay, both are identical. Mass m moves with a speed with another identical. So both are identical. Let us suppose this moves with something angle theta. Okay, this mass moves with some angle theta. M2 is m only. And if this is v1 and what is this? v2. Then resolve the components along x-axis and along y-axis. So v2, what is this now? mv2 cos theta. And what is this? mv2 sin theta. So equate the components along x-axis and y-axis. What are the components along x-axis? So before the collision, the components along x-axis is mv, m1v, m1 nothing but m. This is anyhow 0. After the collision, mv2 cos theta, mv2 cos theta. So mass gets cancelled. V is equals to v2 cos theta. Okay, v2 cos theta. Keep this as a equation number 1. Equate the components along y-axis. What are the components along y-axis? First particle moves perpendicular to the initial direction. Second particle move means y component is this much. So equate these two components. Above is mv by root 3 below m v2 sin theta. M gets cancelled. So I got v by root 3 is equals to v2 sin theta. Let us take equation number 2. Just do the square for first one and second one, then you can go for addition. You will get the direct answer. So squaring and adding equations 1 and 2. So equation 1 and 2 is v2 square cos square theta sin square theta becomes 1. Right side v square by root 3. Okay, so squaring now v square and v square by 3. So how much it is? 4v square by 3. So v2 is equals to 2v by 3. So v2 is equals to 2v by this is root, so root 3, 2v by root 3. So see the first option. So first option is the correct option for this question. Okay. So resolve the components, then you will get the answer. Equate the components along x-axis and along y-axis, and squaring equation 1 and 2, you will get final answer, that is 2v by root 3. Yeah. Go for the next one. See. Next one, direct question. An athlete of mass 60 kg skips at the rate of 20 steps per minute through an average height of 25 centimeter. The power developed is. See, direct question this is. Just use the basic formula and substitute the values and check the given answer. So I hope you remember the power formula. Power nothing but work by time. And see, they given the person or athlete moves a height. No doubt that work is done in the form of what? Potential energy. Work is done in the form of potential energy. So power is equals to, for one step, one work done by time. For n steps, nw by t. How many steps they given? 20. What is this w? mgh by t. So substitute the values and check the calculations. So let me substitute the values, you verify the calculations. So what is the mass they given? 60 kg person. G, you can take 9.8 or otherwise 10. That is your wish. Okay, if you take 10, you may get little difference in the answer like a previous problem. So no need to worry. Okay, better you take G as a 10 and go for the calculation. At the end, you see the nearest answer. If you take G as a 10, you will get nearest answer. If you take 9.8, exact answer you will get. Let us see. 9.8 height 25 centimeter. 25 10 raised to minus 2. 60 per minute. Per minute means time is 1 minute. 60. So 60 cancelled. Okay. 25 2 is 50. Okay. Approximately 50. If it is 10, so nearly it is 500. 500 but nothing but minus 2 is there. Okay. And see 25 into 20. 5000. 5000 into 10 raised to minus 2. Nearly 50. 50. So the nearest answer of 50 is what? 49. So verify these calculations. So check the calculations. So you will get nearest answer is 49. Just multiply 25, 20 and 9.8 and 10 raised to minus 2. You will get 49. Okay. So easy question. So no need to worry. And see the next one. Yeah. See the next question. So this is also, I think, logical question. A body of mass m kg is lifted by a man to a height of 1 meter in 30 seconds. Another man lifts the same mass to the same height in 60 seconds. Then work done by them are in the ratio. Yeah. See, mass m, a body of mass m kg is lifted by a man to a height of 1 meter in 30 seconds, and another man lifts the same mass to the same height in how many seconds? 60 seconds. Then work done by them are in the ratio. You know already work done is independent of time. It then generally depends on gravity, depends on height, means at what height the body is raised. Okay, anyhow this work is done in the form of potential energy, and here we know the work done is depends on only height but not on time. So that it is independent of time means what is the option now? Independent of time means the given option is 1:1. Okay, no change, 1:1. Okay, yeah, go for the next question. See the next question. Yeah. In the figure shown, initially the spring is at its natural length and the collision is elastic. Find the maximum compression of the spring during the motion. Yeah, they given, see what they given is a block which is placed on horizontal surface right now without friction, so there is no problem. And another, this block is going to hit another spring mass system M. This is 2m, spring constant is k. Okay, spring constant is k. Once this block moves with a speed v naught, and if it hits this block, then no doubt this is going to move with certain speed, and means the spring will compress. Next, due to restoring force, again the spring will stretches. They are asking what is the maximum compression of the spring when block M moves with a speed v naught, hits the another block. So no doubt the spring will compress. Let us suppose X is the compression in the spring. X is the compression in the spring, and this body moves with certain speed v. Okay. So anyhow, here this is moves with some kinetic energy half m v naught square, that is equivalent to energy stored in the spring. So here half m v naught square. Okay, half m v naught square, we can write it as half k x square. Here half m I am going to replace with half mu v naught square. See, again I am using one more shortcut. Instead of writing 2 to 3 equations, again I written a one step only, mu v naught square. What is this mu? Mu is nothing but reduced mass. Okay, this is actually two body oscillatory concept. Anyhow, we are going to do this concept in next chapters in simple harmonic motion. Right now again I am using a shortcut formula mu. What is that reduced mass? Reduced mass is half product of mass by sum of the masses. What is the product? M into 2m by sum of the masses, m plus 2m. See, direct we are getting final answer. Half k x square m. So this is 2m by 3m k x square. M gets cancelled. Then they are asking to find, sorry, here into v naught is missing. Okay, so 2 by 3 m v naught square, x is equals to 2 by 3 m into v naught square. 2 by 3 m, and one more is there, k. 2m by 3k into v naught. Into v naught, because square gets cancelled. So see the first option in the given question, root of 2m by 3k v naught. Okay, yeah, go for the next one. So I am using reduced mass concept in the previous one. Now see, one more question is given based on the spring. So read the problem. They given a block of mass m. A block of mass m is attached to the lower end of a vertical spring. The spring is hung from a ceiling and has a force constant value k. The mass is released from rest and the spring initially unstretched. The maximum extension produced in the length of the spring is, see, they given a block of mass m attached to the lower end of a vertical spring. They given, this is the spring whose spring constant is k. A block of mass m is attached like this. the mass m is released from rest and the spring is initially unstretched. If it is released from rest, then there will be a elongation in the spring, and no doubt the energy which is equivalent to potential energy. Okay, if it moves by something h, okay, if it moves by something h, then energy stored in the spring which is equivalent to mg h nothing but just you can take x. So x cancelled. Now what they are asking, x value. What is x? 2mg by k. See, direct final answer. Only one step. 2mg by k. Okay. Yeah. Go for the next question. See the next question. See what they given is, a horizontal force of 5 Newton is required to maintain a velocity 2 meter per second for a block of 10 kg mass sliding over a rough surface. The work done by this force in 1 minute. So work done by this force in a 1 minute. Horizontal force of 5 Newton that is required to maintain a velocity 2 meter per second for a block of 10 kg mass which is sliding down. So which is sliding over a rough surface. Let us suppose, see, this is the rough surface. See, they are not given coefficient of friction, so no need to worry about the mu value. They given something rough surface, and the block has to be moved with a speed of 2 meter per second. Then let us see how much work is said to be done in moving the block on this surface. See, this is the block whose mass is mentioned 10 kg. Mass is mentioned 10 kg. And how much the force they applied? 5 Newton. Force is applied is 5 Newton. Anyhow, force applied on the block is 5. Mass is 10. Then acceleration of the block is very clear. F by m. F is 5. F is 5. So this is a 10. Acceleration is how much? 1 by 2. Acceleration is 1 by 2. Anyhow, we know work done nothing but force into displacement. Okay, force into displacement. And force is given already. How much is the force is given? 5 Newton. S is equals to, so we can write S is equal to ut plus half at square, and here we can write, so S is nothing but, let us write as a at. Is the time is given at. So 5, a is how much? 1 by 2. T how much? T is work done by the force in 1 minute, 60. So how much you will get? So here horizontal force of 5 Newton is required to maintain a velocity of 10 meter per second, 2 meter per second. Velocity is given already. So let me change this one. F nothing but ma s. Okay, so m is how much? M 10 kg. A is equal to, let me write Vt. Okay, so no, we cannot write A Vt. So again 5 Newton, simple question this is, over a rough surface, work done by the force. So work done by the force is theta also not given, mg sin theta, theta also not given. So A is equals to F by m. Fs, F is how much? 5. F is 5. S is nothing but half, let us suppose, if it is half at square, a t square, 60 into 60, so half. So again you are not getting 600 joules. So some value is missing in this problem. So let us use general formula, because theta is not given. See the previous question only. S is equals to, if I use S is equals to V into T, because V is equal to S by T, let us check the given option without taking theta value. So without taking theta means how it is possible? V into T, so 5 into V. V is mentioned already to verify the V value, and time is 60. Yeah, this is also possible. So if they given theta, we can write mg sin theta into S actually, but theta is not given. So better you can go for other alternative method. S is equal to Vt. Then also answer is possible. 600 joules. Okay, actually they have to give theta value. Anyhow, no problem without theta. Without giving theta also, we got this answer. If they given theta, what we have to use? Actual formula mg sin theta into distance. Okay, theta is not mentioned, so no problem. Okay, so actually they have to give theta value. Okay, no problem. Let us go for the next question. Yeah, see the next question. An engine pumps up 100 kg of water through a height of 10 meter in 5 seconds. The efficiency of the engine is 60%. The power of this engine is, I think you know the formula, efficiency. What is the efficiency of the engine? Efficiency nothing but output power by input power. So efficiency, we can write output power by input power. Okay, and if they ask the answer in terms of percentages, you can write the answer in percentages. So efficiency is given 60%, 60 by 100, P output by P input. So 0 0 6, this is 3 is 5 is 3 by 5, power output is, and water through a height is mentioned, so this power is mgh by T, and Pi is our target. So Pi is equals to, take this 5 by 3 left right side, 3 by 5 becomes 5 by 3, mgh, what is m? 100 kg. G again take 9.8 or 10, anyhow in a brackets they given 10. Height, what height the water is going to take? 10 meter. By time, in how many seconds? 5 seconds. So 5. Okay, so this is 3.3 so 3.3, 2 zeros, 1 0, so 3.3 kilowatt. So 3.3 kilowatt, yeah, it is the option number 1. Yeah, see the next one. Yeah, see the next question. A ball strikely a horizontal plane with a velocity v rebounds with a velocity 256 by 625 v after fourth collision. The coefficient of restitution is, see actually what they given is, a ball strikes the horizontal floor with a velocity v and rebounds with some other velocity given after the fourth collision. Then what is the coefficient of restitution? I hope you remember the formula, velocity after nth rebound. What is the formula for a velocity after nth rebound? Velocity after nth rebound is e power n into v. So after the fourth rebound they given 256 by 625 v. So this is given 256 by 625 into v, e power, this is 4, e power 4 into v gets cancelled. So 256 by 625, let me write, this is 4 by 5 whole power 4. Why? Because 4 4s are 16, 16 4s are 64, 64 4s are 256. 5 5s are 25, 25 5s are 125, 125 5s are 625. E power 4, 4 4 gets cancelled. E is equals to 4 by 5. 4 by 5 means how much it is now? 0.8. 4 by 5 nothing but 0.8. So this is simple question. Yeah, see the next one. So this is from NCERT. Okay, same question from NCERT textbook. A body constrained to move along the z-axis. under a constant force, F is equals to minus I cap plus 2j cap plus 3k cap Newton. Work done by the force in moving the body a distance 4 meter along the z axis. Okay, they are asking work done by the force. Yeah, work done by the force in moving the body through a distance 4 meter along the z axis. So they given distance along the z axis, nothing but k cap. You know I j k. Okay, here f is given in terms of I j k and distance is given only plus z axis, nothing but plus k cap. Now the work done by in this force is f dot s. What is f? Minus I cap plus 2j cap 3k cap dot, this is 4k cap, because the distance is given, not the distance actually, that is the displacement. So displacement is along z axis. So z axis means 4k cap. Do the dot product. If you do the dot product 3 and 4, so 3 4s are 12 joules. Okay, simple question from NCERT. Yeah, see the next question. Yeah, a machine which is 75% efficient uses 12 joules of energy in lifting up a 1 kg mass through a certain distance. The mass is then allowed to fall through that distance. The velocity at the end of its fall is. So this is also like a one kinematics problem. And but they mentioned energy here. So machine which uses 75% efficient, 12 joules of energy in lifting up. In lifting up means, tell me the energy in the form, it is in which form? Is it potential energy or kinetic energy? So no doubt it is a potential energy. So indirectly they given the potential energy mgh, which is equivalent to 75%. mgh is equals to 75%. So 75% means how much it is now? 75% of 12 joule. Okay, 75% of 12 joule. So this is 3 za, 4 za, 4, 3 za. Mass is mentioned. How much it is? 1. G you can take, G is not mentioned. So you can take as a 10. Height is the target, 9. So h is equals to, I am getting 9 by 10 meter. This is the height. They are asking to find velocity at the end of its fall. We know the velocity. Velocity formula 2gh. 2 into g is 10. H is 9 by 10. So the answer 2, 9. This is 18. So root 18 meter per second. So simple and direct question. Root 18 meter per second. Okay. See the next question. See, next one what they given is, a body of mass 8 kg is moved by a force of 3x Newton, where x is the distance covered and initial position is x is equals to 2, final is x is equals to 10. The initial speed is mentioned, asking to find final speed. Okay, so they are asking to find final speed. Let us see what is that final speed. See, F is given 3x, nothing but what? Is it a constant force or a variable force? It is a variable force. You know work done by the variable force formula. Tell me what is the work done by the variable force? Work done by the variable force is W, which is equivalent to integration of f dx. I hope you remembered all these basic formulas which are covered in previous classes. So this is 2 meter and 10 meter. Okay, what is this W? W nothing but from work energy theorem, it is half m v square half m u square. Integration of 2 to 4. What is f? 3x dx. What is F? 3x. So mass is given 8 kg and starts with 0 speed. So this is going to be 0 half into 8 into v square. So 3 you write outside. This is x square by 2, 2 to 3. So this is 4v square 3 by 2 x square 9 minus 4 4v square 3 by 2 into 5. Okay, so 3 square 9 and 2 and 10. This upper limit is how much? 2 and 10. 2 and 10. So if you substitute the upper limit, 100 minus 2 and 10 and lower limit 4. Okay, so 3 by 2, 100. This is how much it is? 96. 2, this is 48. 4, 2, this is 12. So v square is equals to how much? 36. V is equals to 6 meter per second. So what is the value of V? 6 meter per second. So simple question this is also, so no need to worry. Okay, see the next problem. Yeah, this is also direct question. Yeah, this is only one step. A ball hits the ground and loses 20% of its momentum, coefficient of restitution. So 20% of its momentum. So 20% of its momentum means, show me the other options. See 0.2, 0.4 and see the given 0.6 and 0.8. So 20% of the momentum, final momentum, which is equivalent to how much it is? 20% loses means remaining is 80%. mu. So direct V by U is equals to 0.8. What is this V by U? V by U nothing but coefficient of restitution. Recall the concept. V by U nothing but a coefficient of restitution. Only one step. So see the next question. Go for the next one. Yeah, this is good question somewhat. A constant power P is applied to a particle of mass m. The distance travelled by the particle when its velocity increases from v1 to v2. Okay, when velocity increases from v1 to v2. Here the given power is constant. Okay, constant power. Anyhow, we know the power formula. Force into, what is the power formula? So simple equation, this is force into velocity, and power is constant. The distance travelled by the particle when velocity increases from, velocity is changing here. Let me write the power or the force in different equations. Let me write this force as m a v. P is equals to m. What is this a? V into dv by dx. Velocity acceleration is equals to dv by dt. Multiply dx, divide with dx. So we can write dx v dv by dx. So this is v dv by dx into v. Power is equals to mv square dv by dx. Let me take dx to the left. m by p v square dv, and use the integration. They mentioned the limits v1 to v2. Here this is x, distance is the x. v1, v2, m by p you write outside, m by p. v square dv means v cube by 3. Limits are v1, v2. Okay, limits are v1, v2. Now after the limits, m by p 3p, v2 cube minus v1 cube. So check the answer, m by 3p cube, yeah, v2 cube minus v1 cube. See the third option, m by 3p v2 cube minus v1 cube. Okay. See one more. Yeah. See the next question. When a 4 kg mass is hung vertically on a light spring that obeys Hooke's law, I hope you remember the Hooke's law from elasticity chapter, the spring stretches by 2 centimeter. The work required to be done by an external agent in stretching this spring by 5 centimeter. Okay. See the given when a 4 kg mass, anyhow you know from force constant you know F is equals to kx. F is equals to kx, but F is not given here. So let us find when 4 kg mass hang vertically on a light spring. Hang vertically, 4 kg mass hang vertically. This is the 4 kg mass, and what is this? This is nothing but mg. We know F is equal to kx. This F nothing but let us write mg. Kx. X is equals to mg by, or otherwise k is equal to mg by x. When 4 kg is hanged, the spring stretches by how much? 2 centimeter. The spring stretches by 2 centimeter. K is equal to, what is m? 4. G take 10. X 2 centimeter. Okay. So K is equals to 2 into 10 power minus 3. See, I got K value. So this is centimeter, 2 centimeter. Okay. 2 into 10 raised to minus 3. Then they are asking to find work done. Let us see how to get the work done. Work done nothing but half K x square. Check the calculation here. Half K value 2 into 10 raised to minus 3. X value, how much x value? 5 centimeter. 5 means 25 into 10 raised to 5 centimeter. 25 into 10 raised to minus 4. So you are getting, this is comes to the top, so it becomes plus 3. 10 raised to plus 3 minus 4. 2.5 into 10 raised to minus 1. 2.5 joules. So 2.5 is not there, means at least nearest answer is 2.450 joules. See the second option, 2.450. So that is possible if I take G as a 9.8. But right now how much I am taking G value? G I am taking 10. So no need to worry in taking G as a 9.8 or 10. If you take the 10, you will get the nearest answer. Right now I am getting 2.5 joules. If you take G as a 9.8, you will get 2.450 joules. Okay. So try to solve the remaining questions. Okay. Try to extend remaining answers also, because the remaining questions also very easy. So I hope that you are going to do the remaining questions. Okay. Thank you.